Did you ever wonder what made Albert Einstein the genius we know him as today? Our story begins in a quaint German city in the year 1879, marking the birth of the man who would revolutionize our understanding of the universe. Young Albert's early education wasn't particularly remarkable, but there was a spark of curiosity ignited in him when he received a seemingly ordinary gift, a compass. The needle's unerring northward swing, guided by an unseen force, deeply impressed the young boy. This was not magic but science, and it sparked a fascination that would shape the course of his life. From that moment, he embarked on a journey of discovery, exploring the mysteries of the universe with an insatiable curiosity. This was the start of Einstein's lifelong love affair with science. Even as a child, Einstein showed signs of the genius that he would become. 1905 marked a significant year in Einstein's life, often referred to as his annus mirabilis, or miracle year. This was a year of extraordinary scientific creativity for Einstein, a year in which he published 4 groundbreaking papers in physics while working in the Swiss patent office far from the academic limelight. The first paper shed light on the phenomenon of Brownian motion, offering empirical evidence for the existence of atoms. The second paper introduced the concept of special relativity, altering our understanding of space and time. The third paper delved into the photoelectric effect, laying the groundwork for the development of quantum mechanics. Finally, in the fourth paper, Einstein proposed the theory of mass-energy equivalence, encapsulated in the now iconic equation E equals mc squared. This theory laid the foundation for the development of nuclear energy. These papers not only revolutionized physics but also marked the beginning of Einstein's rise to international prominence. What is space? What is time? These were the questions that led Einstein to his groundbreaking theory of relativity. At its core, the theory of relativity is a fundamental shift in how we perceive the universe. Einstein proposed that space and time are not separate entities but rather interconnected parts of a four-dimensional fabric known as space-time. In simple terms, it's like a cosmic quilt, stitched together by the threads of the universe. Einstein's theory of relativity is actually made up of 2 parts: the special theory of relativity and the general theory of relativity. The special theory, published in 1905, posits that the laws of physics are the same for all non-accelerating observers and that the speed of light in a vacuum is the same, no matter the speed at which the observer travels. The general theory of relativity, published a decade later, added gravity to the equation. Einstein proposed that massive objects cause a distortion in spacetime, which is felt as gravity. Think of spacetime as a trampoline and a heavy bowling ball as a massive object like the sun. The bowling ball warps the trampoline, creating a dip that smaller balls roll into. That's the essence of gravitational pull. Now let's talk about the famous equation E equals mc squared. This is a simplification of one of Einstein's most revolutionary ideas. It states that energy, E, is equal to mass, m, times the speed of light, c squared. In other words, mass and energy are interchangeable. They are different forms of the same thing. The implications of Einstein's theory are profound and far-reaching. It predicts the existence of black holes, the bending of light around massive objects, and the phenomenon of time dilation, where time slows down for an object moving at high speeds or in a strong gravitational field. Einstein's theory of relativity reshaped our understanding of the fundamental laws of the universe. It's a testament to the power of human curiosity and the relentless pursuit of knowledge. And it all started with a simple question: what is space? What is time? Despite his remarkable contributions to theoretical physics, Einstein's Nobel Prize was for something entirely different. For many, it's a common misconception that Albert Einstein's Nobel Prize was awarded for his groundbreaking work on the theory of relativity. However, the reality is a bit different. In 1921, Einstein was awarded the Nobel Prize in Physics, but it wasn't for his work on relativity. Instead, it was for his explanation of a phenomenon known as the photoelectric effect. This effect, simply put, is the emission of electrons or other free carriers when light shines on a material. Einstein's work on the photoelectric effect provided a compelling argument for the existence of quanta, or packets of energy, a concept that laid the groundwork for the development of quantum mechanics. So while Einstein's theory of relativity may be his most famous contribution to science, it was his work on the photoelectric effect that earned him the Nobel Prize. Einstein's explanation of the photoelectric effect was pivotal in the development of quantum mechanics. Albert Einstein's contributions extend beyond the realm of science. They permeate deeper into the very fabric of our culture, our understanding of genius, our civil rights movements, and even into the creation of nations. Einstein's name itself has become synonymous with genius. His iconic image, the wild hair, the thoughtful gaze, these have been etched into our collective consciousness as the embodiment of intellectual prowess. His ideas and theories have pushed the boundaries of human understanding, forever changing our perception of the universe and our place in it. Yet, it's not just his scientific acumen that sets him apart, but also his humanism and his fervent belief in the power of ideas. Einstein was not just a man of science but also a man of principle. He used his fame and influence to champion the cause of civil rights in America. At a time when racism was rampant, Einstein denounced segregation and racism, becoming a vocal supporter of the civil rights movement. He corresponded with leaders like Webb Du Bois and Paul Robeson, using his platform to amplify their voices and their fight for equality. Einstein's influence also extended to the political sphere, particularly in the creation of the State of Israel. As a prominent Jewish figure who had fled Nazi Germany, Einstein was deeply involved in Zionist causes. He played a crucial role in the establishment of the Hebrew University of Jerusalem, believing in the power of education and science to bring about peace and prosperity. Einstein's legacy, as we can see, is far-reaching, influencing not just the world of science but also the course of history. His life and work continue to inspire, challenge, and provoke thought, reminding us of the power of curiosity and the importance of standing up for what is right. So as we delve into the life and work of this remarkable individual, let's remember his words. The important thing is not to stop questioning. Curiosity has its own reason for existence. Einstein's legacy continues to ignite the spark of curiosity in us all.